Okay, so in this lab, we're going to be doing a paired sample t-test. And so with this one, it's usually coming after a single sample t or an independent t. This is either going to be like a match sample, or you can also call it like well, yeah, I guess the umbrella term is a paired sample. You can do repeated, you can do match, but it's all paired because we're looking on, we do still have raw data, but we're looking more so now for the difference scores. So we have data here. Hopefully you're able to bring up the file I had. So once you have the data in front of you, we can start conducting a paired sample t-test. And again, we're comparing pretest scores and final scores. So you should see here we have pretest, midterm, and final, but for this lab, we're just going to focus on the pretest and the final. So those are making our two variables. Okay, so how we run a paired sample t-test is we go up to analyze, and then go down to compare means, and then go down to paired sample t-test. So again, analyze, compare means, paired sample t-test. And it should bring you up this little paired sample t-test box. And again, the ones we're trying to look at is a pretest, so we're going to click on, pretest. And then we're also going to click on final because we want to see the difference between the pretest and the final. And then under options, definitely make sure it's at 95% confidence level. Yep, okay, so we look good there. And then we can just press OK. We should get an output window that has three different boxes. So in the first box, we have our paired sample, just simple statistics. It's going to give us the mean for both the pretest and the final, how many people we had in that in those groups, standard deviation for both the pretest and final test, and the standard error of the mean differences between those two. Okay, or for those two. The next one is the paired sample correlation. And I know we haven't got into correlation quite yet, but this is, kind of a sneak peek on correlation there. So there's the correlation 0.5 or 53%. Okay, the one we're going to focus on is this paired sample test output. So a couple of things that you want to look at here. We have, the final three columns contain the value of t, the degrees of freedom, and the significance level. So we have t here, so our t obtained is negative 11.646. We have 20 degrees of freedom, means we have 21 subjects or participants that we're looking at, or points. And then our significance is less than 0.001, so we're definitely rejecting that null hypothesis. Okay, now remember back in the lecture part of the class, right, we learned that the paired sample t-test is essentially a single sample t-test. But we're focusing now on the differences. So again, yes, we do still care about raw scores, but the main focus for a repeated measures t-test or a paired sample t-test is the difference between the scores. So we're looking at, yes, we care about the pretest scores, and yes, we care about the final scores, but what we're really looking for in this lab is the difference, how much growth, how much learning occurred from when you gave these little second graders a pre-test in the beginning of August, and then you gave them the final test in May, right? We're trying to capture how much growth or how much difference in knowledge is really there. So with this one, we have, 20 degrees of freedom, significance level of less than 0.001, and our t obtained of negative 11.646. All right, so what can we say about this now, right? Well, paired sample or repeated measures t-test determine whether or not the two means are significantly different from each other, right? And significant values indicate the two means are different. And technically, that means that the samples come from populations with different means, if you want to think of it like that. But again, the focus is always on the difference scores. Now, interpreting the Spss output, if this had a significance, we're running this as a two-tailed test, if this has significance of like 0.474 or something like that, then we would say, no, that's not significant. We would fail to reject that null hypothesis. But with this one, our t obtained is so large, and you can bring out your t table if you want to compare it. You know what the degrees of freedom are. You can find your critical value of t if you want to compare it to that, and compare it to your t obtained. So in your lab this week, what I want to see is, I want to see this first. So take a screenshot of like all of this, the three output windows, and then I want you to add some dummy data into it. So you're going to close out of that after you save it or take a screenshot of it, and then go through and add some more dummy data in here. Maybe do 5 or 6 more, and then run the analysis there. And you can try to make it so it doesn't reject the null hypothesis, or you can just make it even, blow it out of the water even more for that. So you're going to have 2 separate screenshots with 3 windows in each one of those screenshots. Reach out to me and message me if you have any questions. All right, thanks.